go to see now how we can deal the line, the angles, and many other aspects that is regarding our analysis in video. So we catch one video and I show you now regarding the line. So we established that it's possible to analyze any angles even without having 3 points that normally is possible, is necessary to have in order to analyze one angle. You know that one angle, this angle for instance, require 1, 2 and 3 points in order to analyze angles. So with BioMovie now this is not necessary. We have an angles here in this line, and I will show you what I intend. If I click with the right button in my mouse, you have a window in which you have a rotation of this line. So you have a rotation angle. I change now the rotation angle and I show you why we can analyze angles without having 3 points. For instance, the side that the rotation angle is 0, and you see that here, the line is completely horizontal. If we says 360 and we change, doesn't change. And now you understand why. We write, for instance, 120, and I change in 120. I write 180. Sorry, 180. And you see that I have my line here by the other side. If I write 200, 210, okay, 240, 200, 260, 280. So you see it's around 70. So, excuse me, 70. So you see that I have a possibility to analyze or to put my line according a sort of watch, okay, in which I have 0 or 360, 90, 180, and so on. So this is interesting for us because in this way we can analyze any angles or any position or any object in the video in which we want to catch information. We have another information about the line. For instance, imagine we delete that we know this size. For instance, this size is 2 meters. So we catch 2 meters. And we calibrate in 2 meters is 200 centimeters. Okay, we have calibrate our measurement now. If we take a line, now our line can analyze the length of any object in our video. So for instance, we can discover the length of any object in a video. Of course, this size is not correct, but we can analyze, imagine a sort of a system to analyze the height of our athletes. And of course, this I told you is not 2 meters, it's probably more. and if you see, if we change the measurement, it change completely, of course, the size in our subject, and we try to catch another in data, and we try to make an analysis. Okay, but this is only an experiment. So I can change the measurement of my line, taking in consideration the size in my measurement. This in order to tell you how much is important to have the correct measurement in the field, and probably not in this side, because you know that this side appear longer respect this side. So in order to have the correct measurement, the best solution is, we delete now all object. The best solution is to take our line, to tract a field in which we are recording like this. So still imagine that this is 2 meters. This is a rectangle. Okay, now the new line, sorry, now the calibration tools, we bring the calibration tool exactly in the middle, and we establish that this is 2 meters. Okay, for instance. And in this way we can of course change, and we can move our calibration tools in arranging according the correct measurement. We have another possibility in our line object, and I show you now. So still imagine that we can take a measurement distances. We redo. I do another time for you the system to catch the data, and we say that, for instance, is 2 meters. I repeat, is not correct measurement because I don't remember the exactly distances from these 2 points, but I imagine are more than 2 meters. We catch this data line connected to both fan. So look, now we have another the jump. We wait a moment with each jump. Okay, go the moment perfect. We take the line. We bring the line, one line we put it here, part of the line here, and the second part of the line we put in the white line. Okay, we go here in a connected line, and we says show time or show distance or show angle, and I say show distance for this moment. Remember, the angles is regarding the position of this line. I want a line perfect right, so I put 0. Okay, show distance. I go ahead and it follow my foot, giving me a distance. And I can show the angles also, because in this way I can see the changing of the angles regarding jump, and I can analyze the movement of my athletes in any direction of the space, having centimeter. I go ahead second jump. So the better way is to have a marker very close to the foot, like here the line, the white line, in order to analyze from the position of your foot to the area in which the foot touch with the ground, the movement. You see that we are finished our analysis, so we go end of the video. Go ahead. And now what is interesting to do after the third jump is to connect any information, and you understand also the importance of the high quality video, to connect any information with a graph to analyzing jumping in a very innovative way. You see the angles. Look how the angle changed in the last jump. The last jump of my athlete. Go ahead. So we finish here the jump. We decide to disappear now. We export data point. We write jump file. We save. Okay. We says no. We can close. Sorry, we can catch now the CSV file, jump. Okay, and we have in here okay, and we can analyze now our graph. We have an angles and we have a distance. You see the graph, okay, the length and the angles. Here is possible to connect, you remember, or to coordinate with the movie, but it's also possible to have, for instance, regarding the length of the height of the jump, to have a minimum, to have a maximum, and to have an average of the 5 jump. That I think is a very interesting information. Even the average of the angle, as the angle change respect the 0 or 360 or the 90 degree or the starting angle is very important. To have an information on the movement that our athlete did during the test. So we coordinate or we connect the data with the movie, and we have a very innovative way to analyze jump. Thank you for your attention, and we will see in the next and last tutorial of BioMovie.